Okay, so a constant does not have a letter, doesn't have a variable, it's just a number. So for example, like we just saw, -1 is a constant. It's always -1. +4 is always +4. If I have $4 in my pocket, that's not changing unless I spend it. It could be a fraction, -3/4. It could be a decimal, 2.85. All of those guys are what we call constants. They don't have a variable. There's no change. If something doesn't vary, it stays the same. Okay? That's where variable comes from, because it changes. Right? The next one is linear. Linear. The one we just looked at. 2x minus 1. Right? Even though you're like, it doesn't have a power, it does have a power. We just don't write it. It's 1. Right? -3x plus 4. Those are all linear. If we graph those, they would be straight lines. We did graph them. Some of them were dotted, dashed. Some of them were solid. Right? We just took that test. They were all straight lines, no curves, no nothing. Today, we're going to focus on this one right here. That's what this chapter focuses in on. Next chapter will be cubics and quartics. But this chapter is just quadratics. So the highest power is 2. So let me give you an example. 4x squared minus 5x plus 3. The highest exponent power is 2. When I graph those, it's going to look like this or this. It's going to look like arrows up or arrows down, a parabola, a U. Okay, always. If it doesn't, that means it's not a quadratic. Cubic. Cubic means there is a third power. The highest power is now 3. Quartic. Quartic means the highest power is now 4. Okay. Cubic and quartic, that's next chapter. We're going to work on those next chapter. This chapter, we're only focusing on quadratics. First chapter, the one you just took, we saw a lot of constants and linears. That was the first chapter. You guys done with that? We took the test. We're done with that. Now this chapter is quadratics. Next chapter will be cubics and quartics. Okay. Okay, so when we graph a quadratic, this is what we call a positive quadratic. Why is it positive? Because arrows are up. Arrows are going up. It's either going to look like arrows going up or arrows going down. Okay? It's got a lot of different parts to it. So when I say the graph, I mean the red part. It's not red on yours, I know, because I don't have a color printer, or a color copier, but oops, that's not what I wanted. Yes. The word parabola, does that mean U? Yes. Anything that moves, like sometimes you'll say it has a parabolic shape. That means it's a U. Yeah, great point. When I throw a ball, doesn't matter what type of ball it is, softball, baseball, football, that's a parabolic shape. Because if I were to throw it, it's going to make this shape here. That's a parabola, right? I don't care how hard you can throw. I don't care. Oh, no. Some people say, no, my throws are straight line. Nope. That's gravity, right? Gravity is always pushing down, right? Gravity is always pushing down. So there's no way we could throw in a straight line. Hey, what's up?
Hello, we just wanted to ask.
Yeah, we got it. Yeah, we got it. Thanks. So if you were to draw, there's no way anything moves in a straight line unless there's zero gravity, right? So anything we throw is always a parabolic shape.
Now, do you only measure the parabola shape from like the point that you throw it to the point that it lands? Because what if you throw it and then the point is like actually lands on the ground?
That's a good point. So those are what we call x-intercepts, and we're going to talk about that. We're going to talk about how to solve those. Yeah, for sure. Okay. So the shape is called a parabola. Parabola. So that's the shape here. Axis of symmetry. It's green. I put it green on mine. Over here, it's a dashed line green. It cuts it in half. Symmetry means if I fold it, it's the same, right? Symmetrical means anything symmetrical means if I were to draw a line, cut me in half, it would be exactly the same on each side. Well, not exactly, because there might be some freckles I have here that I don't have over here, right? So anything symmetrical is perfectly cut in half. That's what that green line is doing. Okay. The next thing is it's got 4 names. So I put them all down. Sometimes they're called x-intercepts. Sometimes they're called roots. Sometimes they're called solutions. Sometimes they're called zeros. Anywhere it crosses the x-axis. If it crosses the x-axis, those are all called x-intercepts, roots, solutions, zeros. They're all the same thing. But sometimes you'll see it'll call it zeros, find all the zeros. And sometimes it'll say find all the x-intercepts. Sometimes it'll say find all the roots. What's the solution? That's what we're talking about. Okay. The next one, y-intercept, we've seen that before, where it crosses the y-axis. It's not a starting dot anymore. That was only for linear. Okay, where it crosses the y-axis. And then the last thing is called the vertex. If it's arrows up, the vertex is going to be at the very bottom, so we call it a minimum. If it arrows down, it's the opposite. We still call it vertex, but it's going to be the maximum. Maximum is the top, minimum is the bottom. So it's going to have one or either. It's not going to have both. It won't have a minimum and a maximum. It'll either have one or the other. Okay, so that's all we're doing today. What we're doing is we're just identifying those things. I'm going to give you 3 pictures, and I want you to identify them. Okay? With a few new ones that I'm going to add in today. All right, so let's look at the back. Okay, so graph A. We'll start with graph A. Graph A has arrows up. So the first thing I got to do is find the vertex. Well, the vertex, if it has arrows up, is going to be on the very bottom. Right? So let me go find the dot of where that is. It is right here, right? So if I was to tell you where that dot was, what are the coordinates? -1, -4. -1, comma, -4. That would be the vertex. -1, comma, -4. That's where it's located. That's where the very bottom of the graph is located. Is graph A, going to have a minimum or a maximum? It's going to have a minimum, right? So what do we put for the maximum? Nothing. Just put a little. This one's not going to have a maximum. It's not going to have one. When we put the minimum, we're not going to put the dot, -1, -4. They just want to know where the bottom is. So which one of these tells me the bottom? -1 or -4? 4, -4, right? That's where the bottom is. -1 just tells me left and right. -4 tells me up and down. So they just want -4. So that's all we're going to put there. is negative 4. Okay. Line that gets cut in half. The line that cuts everything in half. It's always going to go through the vertex. Always going to go through the vertex. It's a straight line, vertical line. Where does it pass through? Negative 1, right? So we're going to write it as an equation. X equals negative 1. X equals negative 1. Because it's a line. If I just put negative 1, that means a dot. It's an equation, so I have to put x equals negative 1. Okay. Y-intercept. Y-intercept. Oh, thanks. Where does it cross the y-axis? That pink dot. Right? How do I get to this pink dot? Don't say negative 3, because if you just say negative 3, I'm going to be like, oh, that's it right there. So how do I get to this dot here? What dot? How do I get, well, let's start with one that we know. Yeah, let's start one we know. This dot right here was negative 1, negative 4, right? So what is this dot, the pink dot, going to be? 0. There you go. 0, negative 3.
And you only put coordinates in parentheses?
Yes. If it's a coordinate, put it in parentheses, yeah. Okay. Next thing is, where does it cross the x-axis? Well, this guy's going to cross a couple times. Crosses there at the blue dot and the blue dot. Again, those are dots, so I need to be able to tell where the dots are. So the first blue dot is at negative 3, 0. The next blue dot is at 1, 0. Sometimes it'll have 2, sometimes it'll have 1, sometimes it won't have any. Okay, so those you guys have seen before. Math 2, that's we talk about vertex, minimum, maximum, axis of symmetry, y-intercept, all those, x-intercepts. The next ones, sometimes we don't talk about it. That's why it's more of a Math 3 thing. Increasing decimal, or interval. So first of all, what does that mean? Well, what in the world does that mean? Well, let me write this. Let me erase all this first. Okay, so let's start with the word increasing. What does increasing mean? Gaining or going up, right? Going up or gaining, right? Okay. What is interval? I'll give you a hint. Our schedule is based on intervals. We don't call them intervals, we call them periods. Period 1, period 2, right? They're smaller segments of the whole, right? We start at 8:30, we finish at 3:35, right? But you don't spend that all in one place. You spend it in first period, and then second period, and then break, right? And then third period, fourth period, lunch. Those are all intervals of time, smaller pieces. Okay? So we have to find the pieces of this graph, the U, parabola, where it's going uphill, gaining value. Okay? So this is how you do it. You start at the left arrow. So watch me first and then do it on your own. Start at this guy right there. And then I'm just going to follow the graph. Well, from there, the graph goes down. And then it goes back up. So what I want to know is, where was my pen going uphill? There you go, right? It started at the vertex, right? Didn't I start going uphill right there? That was at negative 1. So it started going uphill at negative 1. Write this down. Uphill. Write little notes to yourself so that you remember what each of them means. What does increasing interval? It means going uphill. So we said it started at -1 going uphill, right? So I'm going to write it in parentheses, kind of like a dot, but it's not a dot, it's an interval. So it started at -1. So let me erase where it wasn't going uphill. Okay, it started there, right? It started at the red dot. And then when did it stop going uphill? How do we know never? The arrows, right? The arrows make it say it goes forever, right? Okay, so I'm going to give you a little hint. This arrow, I wrote it up there too, but just in case you didn't see it. This arrow represents positive infinity, forever and ever and ever. This arrow represents the opposite, negative infinity, forever and ever and ever and ever and ever. What's the difference between them? If they're both going to forever and ever and ever, what's the difference between them?
Well, one is constantly decreasing. Constantly.
They're going in the opposite direction, right? They're going in the opposite direction. One is going to the right, forever and ever and ever and ever and ever. One is going to the left, forever and ever and ever and ever and ever. That's what I mean. Okay. So we said we started at -1, right? And then we kept going to the arrow, right? And what does the arrow represent? Positive infinity. So that's what we're going to write down here. Sideways 8. It means it starts at -1 and then it never stops going downhill. It never changes. It always increasing. Okay. Decreasing is the same thing, but downhill. Downhill. So let me use a different color. Start over here. We always start at negative infinity. From negative infinity, am I going uphill or downhill? Down. When do I change? At -1. So that means the start was the arrow. The end was -1. Okay.
So for every equation, like you said, is the opposite, you just reverse those two terms.
For quadratics, yes. For quadratics, yes. So this chapter, yes. Yeah, this chapter, you'll always be either increasing or decreasing. That won't always be true next chapter, but for this chapter, yes. Okay. So we started decreasing up until -1, and then we flipped to increasing from -1 on. Okay. The next one is positive and negative interval. Same interval, right? So what does positive mean? Positive, another way of saying positive interval is above the x-axis and below the x-axis. One is above, positive is above the x-axis. Negative is below the x-axis. So I kind of think of the x-axis as like water, right? When you're out of water, you're above the x-axis. When you dive in, then you go below the x-axis. And then you come back up, right? We got to come back up. All right? So let's look at graph B again. So I'm going to erase what I've drawn so far. Okay. So where's the water level? X-axis is the water level. When am I above water? So let's go 1 through 1. So let's start over here. Am I above water or below water up here? above. I'm going to go. Tell me when to stop. Tell me when I get underwater. That's where I cross the water. So after that, I'm below water. Now I'm below water. Now I'm coming back up, right? And then when I cross that, I'm above water again. So there were 2 instances when I was above the water, above the x-axis. 1 instance when I was below water, right? You dove in, then you came back up, right? So we're going to write that. Okay, so let's start with the easier one. The easier one is probably below water. So below water, when do I start below water? At where? At -3. And then when do I come up? +1. So I was below water, negative, from -3 to +1. That's when I hit the water, came back up, popped out at +1. Where was I every other time? Above water, right? Above water. So underwater is the blue, right? The blue is the underwater. So where is the orange? Well, where does it start? -infinity up until it stops here, -3, right? And then it picks up here from to +infinity. So let's write that down.
Is that 2?
So it's 2 intervals, yeah. So it's 2 intervals, not 1. You can't say from -infinity to +infinity because it wasn't. This part here, I was underwater. The blue part, I was underwater. So let's write this down. It's going to be 2 separate intervals. The first one was -infinity to -3. And then +1 to +infinity. Started out of water. -3 is when I went underwater. Underwater until 1. The rest of it, I was out of water. Okay? Above the x-axis, below the x-axis. I just use that water because it, everyone can kind of think of a pool when you're jumping in, or a lake or something. The ocean when you jump in. Okay? So if you want, the math behind it, so the actual math, I can't tell you because I don't know. I'm not a fortune teller. I can't tell you what you guys are going to be doing. And, when I was your age, I didn't think I'd be doing this. So I don't know. I can't tell you that. But it's not necessarily the math behind it. It's the thinking, right? It's the thinking. This is going to the gym for your brains. This is going to the gym for your brains, right? If you want to get muscular, you go to the gym and lift weights, right? This is doing that for your brains. If you kept doing the same math over and over again, your brains wouldn't get any stronger, right? The brain, this is the moneymaker right here. The brain is the moneymaker. If you make lots of money in life, it's because of your brain, right? So that's what you're doing now. Now, if you want a math that is like, oh, this is how, I can use this in real life. Mr. Feistel's senior math class is the class for you. All he does is real life math, money and stuff like that. So if that's what you want, that. But what we're doing in here is mental lifting so that your brain can be stronger. The stronger your brain is, the better you're going to be, the better you're going to get, the better job you're going to get, the more money you're going to have. That's why we do it. Okay? That's why we do it. Okay? But yeah, if you're going to ask me, when am I going to use this? I don't know. I'm not a fortune teller. I can't predict the future. If I could predict the future, I would have won the lottery lots of times already. I can't. So, I don't know. Come back and talk to me when you're 25, 30 years old. Then I'll tell you. Mm-hmm. Yeah. But more so than that, what we're doing, like I said, is we're going to the gym. Every day we're going to the gym. From what time to what time? It's just for your brain. Okay? The more it hurts, if you go to the gym, right, and you lift weights or you run, cardio, don't things start to hurt afterwards? You get sore? You're like, right? If you get used to it, then you got to start doing more, right? You got to start lifting more because your muscles are getting used to it. And why can't we do the same math we do in third grade, multiplication for the rest of our lives? Because then your brain's just going to turn to mush because you're not pushing it, right? If I just went to the gym and picked up two pounds and just went like this, 2 pounds, put them down and went home, my muscles wouldn't get any better, right? You do that every day.
Are you suggesting that by doing this math, we're training our brain to do other things in life?
Yes. Like problem solve. Yes, problem solving. Problem solving, yeah. The one thing, I'm going off on a tangent here for a little bit, but the one thing that it doesn't matter what job, every person out there who hires says they want their people to do is to problem solve. They don't want to tell you what to do. They want you to figure it out on your own. That's kind of like what we're doing here. We're just using math. We're using just math. Right? Then you find another job.
I agree.
Then that's why education comes in. Because if you have education, you can tell them, I don't need your job. I'll go take this job. Right? That's what I tell my son. I'm like, if you want nice things in life, education's the way. Because it gives you options. It gives you options. I don't need this job. Right? If I just graduate from high school, I can work this job. But then what happens if I don't like that job after 5-10 years? I mean, my options are limited, right?
In comparison to somebody who went to college.
There you go. Yeah. All right. That's what education is. It just gives you options. Now, some people don't need those options. Me, I did. I needed those options. So that's why I went to college. Okay. Okay, so let's get back to this. Last two things, domain and range. So domain are the x values. Domain are the x values. Range is the y values. Okay. So the domain, so let's go look at our picture again. So let me take away all the highlighting because we don't need that anymore for this one. So if I were to, so the domain, what I want to do for the domain is I want to restrict it, put it in a box, right? So let's say I say one side of the box should be here. The other side of the box should be here. That's the sides of the box. Would that contain the graph, or would it bust through the box? Would it contain the graph, or would it bust through the box? So in other words, is the graph getting wider and wider and wider? Yeah, you can tell that, right? Where does it start? It starts right here, right? And then it gets wide. It's going up, but it's also getting wider, right? It's also getting wider. So guess what? It's going to keep getting wider and wider and wider. When will it stop getting wide? How wide will it get?
Infinity, right?
Yeah, we don't know. So that's why we say it never stops getting wider. So we say from negative infinity to positive infinity.
And that's because it's in proportion to where it starts, which is negative infinity, right? So
Yep. There you go. There you go. The range is the only time we look at the y values. So the range is the bottom to the top. So let's go back to my picture. Now I want to put a box on the lid. Where would the top of the lid be and where would the bottom of the lid be? So let's go to the top. Could I put a top of the lid here or would it bust through? It would bust through, right? Well, where would the top be? It would be infinity, right? Okay, so infinity is the top. What about the bottom? Where would the bottom of the box go? Yeah, -4. Is it ever going to come back down to -4? No, it's a quadratic. They do this. They either go up forever, ever, or go down. They don't switch. They don't change directions, right? So we say the bottom is 0, or sorry, the bottom is, what did we say, -4? And we said there is no top. There is no top.
For the range, doesn't matter if it's negative, positive.
So the range, so this is the top, right? So it's not going to be negative infinity, it's going to be positive infinity. Mm-hmm. Yeah, the top will always be positive. The bottom will be wherever the bottom is, yeah. I'll give you a hint. For these range, one of them will either be infinity or negative infinity. The other one will be a number. Okay. Okay, so let's do that again. Now let's look at graph B. Okay. Vertex. Well, this time the vertex is up top, right? The vertex is up here. 3, 0. Does graph B have a maximum or minimum? Maximum. It has a top. So that means we're going to put a line through or X through minimum. It's not going to have a bottom. It's going to have a top. What is that top? 0. 0, the Y value. Because the Y is the one that measures top and bottom. Where's the green line that cuts in half? It's going to be a +3. Yep. It's going to be a +3. So X equals 3. Where does it cross the y-axis? 0, -9. Good. 0, -9. Okay. Where does it cross the x-axis? So it doesn't cross. It touches the x-axis. Where does it touch the x-axis? At 3, 0, yeah. So I've had some students put nothing there because they're like, it doesn't cross. Well, it can touch too. It could touch. It doesn't have to cross. It just has to touch. Only one time, though. Okay, so now increasing and decreasing. So start at the left arrow. Am I increasing or decreasing? Increasing. When do I stop? At 3, right? And then it picks up after 3, and I decrease the rest of the way, right? So where is the interval I went uphill? From -infinity to 3. And then I picked up going downhill from 3 to +infinity. Okay. Above water, below water. So the water line is the x-axis. So am I going above water? Wait, give me 1 second.
Do we start at 3 for this?
So you start at the left arrow. Always start at the left arrow. Yeah. So down here, am I below water or above water? Below. I'm underneath, right? And then I go up, I go up, I go up, I go up, I go up. Do I ever come out of water? No. So where am I above water? Never. So we put a 0 with a line through it. It says doesn't happen. It does not happen. I don't come up above water. I'm only below water. From where? From one arrow to the other arrow. Hopefully eventually I come up, but not in the graph. Domain. Is it going to get wider and wider as those arrows go down further and further? Yes. I'm going to give you a big hint. For quadratics, the domain will always be the same. Negative infinity to positive infinity, because they always get wider as they go up or they go down. Range will change, but domain will always be the same. This one doesn't have, it has a maximum, right? So that means, where's the top, sorry, let's start with the bottom. Where's the bottom of that guy going to be, of B? Negative infinity, because the bottom is somewhere below water. The depths, we don't know how far that is because it's so far down. Where is the top going to be? So 3's up here. 3's up here. 1, 2, 3. So 0, yeah. The x-axis, yeah. Okay. Okay. So the last thing we're going to do is I want you to do graph C on your own. Graph C. I'll give you the answers in about 7 minutes. All right. I'll pass around the tape so you can tape it in while you're waiting. So you're going to fold and tape. Okay. So you can tape it in. So graph C. The one I'll give you is domain, because domain is always negative infinity to positive. Answers. So if you haven't seen my answers, the vertex for C would be 2, 1, right? 2 up, 1. It's not going to have a minimum. It's going to have a maximum because it's arrows down. The line, the axis of symmetry is x equals 2. The y-intercept is 0, negative 3. And then there's 2 spots it crosses the x-axis, 1, 0, and 3, 0. Okay. So now where is it going uphill? Well, we start going uphill down here, right? We start going uphill, and then it looks like I stop. I reach my peak, top of the mountain at 2. So negative infinity to 2 is where I am going uphill. And then at 2, I start to go downhill. When do I stop going downhill? I don't stop going downhill. So 2 to positive infinity. Okay. When am I above the x-axis and when am I below the x-axis? Well, let's see. I start below. Then I go above. And then I go back down below. Right? So the orange is negative interval. The blue is positive interval. Right? It's where I pop up out of the water. and go back down. So we go from negative infinity to 1, and also 3 to positive infinity. That's where I'm below water. Where am I above water? 1 to 3. 1 to 3. So I'm above in one spot, 1 to 3. Below everywhere else. So tomorrow when you're doing this, I'll have I'll have markers out. So sometimes it helps when you draw your markers. You draw to where is it above, where is it below? Domain is always the same. Negative infinity to positive infinity. If it's a quadratic, it's always going to have the same domain. Last one, the range. The bottom is not going to have a bottom. There's no way for me to put a bottom because it's always going to bust through that bottom. So it's negative infinity. The top, it will have one, right? The top, it will have one. Positive 1. And that's it. So tomorrow I'm going to give you 4 pictures, and I'm going to have you do the same thing on your own. Okay? That's what we're going to do tomorrow. So again, there was no adding, there was no subtracting, there was no multiplying, dividing, there was no split the symbol, right? There was none of that. But it's a lot of identifying things.